Welcome to the ChatQ&A demo. This AI-powered chatbot uses Retrieval-Augmented Generation to answer enterprise questions with precision. In this walkthrough, we'll provide a comprehensive overview of the architecture, setup, running, and customizing of the ChatQ&A Sample Application on EMT-flashed Intel Edge AI systems. To initiate the deployment, we begin by verifying that the Kubernetes cluster is active and operational. This confirms that all system pods are healthy and visible across namespaces. Next, we create a working directory named Test and navigate into it. From here, we pull the Helm chart for our AI application using the sudo Helm. This downloads the chart package from Intel's OCI-compliant Docker registry. Once downloaded, we list the contents to confirm the chart file is present, and then extract it using tar. The extracted folder contains essential files like chart.yaml, values.yaml, and Kubernetes templates, which we'll use to configure and deploy the application in the next steps. This values.yaml config file defines parameters for deploying an AI-based application using Helm. It allows users to customize image sources, proxy, model configurations as shown here without modifying the core chart referenced in user guide. With our configuration in place, we move to the Kubernetes deployment. First, we create a dedicated namespace called apps to isolate our resources. Next, we apply network policies to securely control traffic in and out of the application pods as configured here. Finally, we deploy the Helm chart using the Helm install ChatQ&A apps, which launches the AI application into the cluster. After deploying the Helm chart, all application pods in the apps namespace are running as you can see. This confirms that the backend, UI, and proxy components are successfully deployed. Next, verify the Helm deployment by running Helm list. The output confirms that the ChatQ&A core release with app version 1.0 is successfully deployed in the app's namespace. To check service exposure, we confirm that ChatQ&A core is exposed via cluster IP on port 8888. Since cluster IP is internal to the cluster, we use port forward to map it to our local machine, making it easy to test and interact with the application directly from a browser. With the application running, we now inspect the logs from the ChatQ&A core pod to verify backend initialization. The logs confirm that we see a successful login to Hugging Face, confirming application is ready to serve AI-powered responses. The app then loads three models: Intel's Neural Chat for natural dialogue, an embedding model for semantic search, and a re-ranker to refine results, powering accurate and responsive AI conversations. The system is now converting all models to OpenVINO format, optimizing them for faster and more efficient inference on Intel platforms. This ensures the AI application delivers high performance at the edge. With all services running, we now access the ChatQ&A application via the browser at localhost. The interface loads successfully, confirming that the front end is connected to the back end. The prompt in the input box indicates that the AI model is ready to respond, but requires context to generate accurate answers. This ensures that responses are grounded in relevant data, enhancing reliability and precision. At this point, the application is fully deployed and ready for customer interaction. This is another example from our demo, showcasing how our system intelligently handles document-based queries using the re-ranker AI model. We upload an OpenVINO feature document and query how does OpenVINO perform benchmark testing. The system instantly scans the document and returns a precise answer, explaining how OpenVINO evaluates model performance across hardware platforms. Powered by the re-ranker AI base model, it ensures the most relevant content is surfaced, turning static documents into a smart, interactive assistant. Thanks for watching the demo.